the image that you see before you was created about 4,000 years ago.
I'm sorry. If I didn't turn on, oh, you did.
Can you hear me? How's that?
Yeah.
All right, great. So what we're looking at here is a painting from ancient Egypt about 4,000 years ago. It's depicting the cult of the god Min. He was the god of fertility and potency. And here he's being carried along on a platform, and he's being followed by two servants that on their little platform have a ritual plant that was often associated with him. In fact, it's depicted nearly every place that he occurs as well. And if you can move beyond the more prominent features in the forefront, you can see in the background the plant depicted in greater detail. And here you can see its erect and spiny form, the upright habit, and if we were to break off a piece of it, it would exude a white latex. And it was these characters, as well as its use as an aphrodisiac in ancient Egypt, that brought it this association with the god Min. And we're fortunate in knowing today the identity of this plant. In fact, we have wild forms of it that we frequently encounter in fields and lots. However, we're more familiar today with its domesticated form. In the process of domestication, its spines were lost, its habit was shrunk and transformed, and it generally became, it lost the potent qualities of its latex as well, which upon testing in the wild relative, opiate qualities were discovered. So the form that today we enjoy has changed a lot from its original appearance in these early works. This is one example of many. This is the story of many of the crops. But for those of us who have cultivated it, we know that it has a tendency, when left unattended, this is Lactuca sativa, or table lettuce, if anybody missed that. But it will quickly try to resume its upright form, and the leaves will turn bitter as the secondary compounds come back before flowering. Perhaps it's dreaming of its former glory. So many other plants were of very important cultural use in ancient civilizations such as Egypt that if we were to run into 4,000 years ago, we would barely recognize. There's a number of crop plants and spices that were used in embalming rituals and mummification practices long before their uses as food emerged. For instance, a ritual incense was created by blending together cassia and cinnamon and figs, honey, oils from cypress or from cedar and juniper were used to rub the corpse and stuff the abdominal cavities, and all of these contributed to the preservation process. So this is a story that's repeated itself again and again throughout history, throughout different parts of the world. And they all contribute to the rich cultural history that plants have inherently. Domestication is this ongoing process through which plants are changed, both unconsciously and consciously, by human selection as our needs, technologies, tools, and the ways in which we change the environment around them continue to affect them. And when we consider the cultural history of crops, we often end up with unlikely assemblages of plants for similar purposes. So for instance, these plants are all united in their distinction as early forms of currency in different cultures. Before these were food, they were often used as toxins and poisons, abortifacients, fish stunning mechanisms, etc. And these represent food plants that were just domesticated in the last 200 years. Some of them much more recently than that, in fact. So understanding domestication trajectories is a way in which we can continue to understand and conceptualize the evolution of food according to our needs. This has been an ongoing theme, a recurrent theme throughout this conference, the syndromes that are not recognized traditionally in domestication literature that we nonetheless recognize as changes plants undergo. So in this talk today, we're going to consider the trends in these domestication trajectories and I like the term trajectory because it does not tell you where you're going to end up, because that's variable and changes across culture and region, as well as the diversity of use plants that we use, and the wild diversity from which we draw our useful plants, and the many ways in which they're changing and interacting. In considering these changes, we also must consider the landscapes in which this enormous diversity evolved, both the natural landscapes in which crop evolution, plant evolution, and radiation first occurred, as well as the cultural landscapes where management has continued to maintain and build our diversity base of crops and other useful plants. We must also consider the ways in which our transformations of these landscapes are continuing to affect crop diversity as well as wild plant diversity, and the many changes at different levels, from climate change to land use change to the introduction of pests and diseases that are shaping diversity as we know it. We've often taken for granted these links between wild and cultivated plants, but it's a recurrent theme in the literature. If you look back to Vavilov's early centers of origin in 1926, although they were conceptualized much earlier than that, this was the conceptual model and the basis for a map that we all recognize, as well as colleagues in other fields related to conservation, which are MEYER's biodiversity hotspots. There's very close, obviously, correlation between the regions in which wild biodiversity and crop agrobiodiversity evolves in its origin, as well as linguistic regions of diversity around the world. So the link between wild and cultivated diversity and culture is very prominent. But first, we need to take stock for a minute and think, what do we know about plant diversity, or rather, what do we think we know? Because the evidence base is still variable, but we're going to talk about some basic parameters. So there have been estimates ranging from as many as 400,000 to 200,000 different species of plants, but for the sake of argument, we're going to settle around 380,000, which is more accepted. Of these, there's about 75,000 different edible plant species that's been estimated, of which, over the course of human history and evolution, perhaps 30,000 have been used as food. And this is based on observations of primates and our close ancestral relatives. Of these, perhaps 2,500 to 7,000 have come under domestication at some point or another throughout human history. So since that chart's getting a little bit smaller and smaller, we'll just consider here those plants that have been under domestication, so around 6,000. Of these, about 830 are considered to be critical to human nutrition. So this is in global reviews of different plants of local importance, so minor crop plants, as well as the major ones we recognize. More or less 100 to 120 contribute to about 90% per capita food intake. This is also considering minor plants, minor crops. The statistic that we're more familiar with, perhaps, is this 20 to 30 plants that supply about 95% of human nutrition. So if we take these plants and put it back into this bubble of plant diversity as a whole, it's barely registered on the chart. But our crops provide much more than food. They bring us a range of goods and services and commodities, and it was also often these early uses for purposes other than food that brought them into domestication in the first place. So as crop diversity declines and threats to natural diversity increase, what's happening to these other uses of plants and how have they changed over time? This is a research project I undertook with two colleagues here, Rachel MEYER and Helen JENSEN. The concept actually began after the meeting in Jalapa in 2010, here at one of the SUB meetings. And we spent 2 years after that mining the literature for data on the domestication syndromes and origins and early uses of 203 different minor and major food crops. And we coded these according to about 36 different categories relating to both their natural and life history traits as well as their cultural and use traits. And we analyzed this data set based on domestication syndromes, centers of origin, records of wild use. For the purposes of this talk, I'm just going to focus on original uses and current uses. Domestication, in the sense of the term as I'm using it here, refers to the beginnings of cultivation or the beginnings of management practices. The term itself takes its root from domus, or house, so it was literally bringing into the house. But there's many different forms that this can take, sometimes intended, other times as a byproduct or refuse, sometimes through trade, other times directly from the forest or surrounding landscapes. And we were curious to know whether across a broad and taxonomically, globally representative database, whether the different classical theories in domestication literature would be maintained. So what happens when you actually move away, you blind yourself from the crops and you're just looking at the categories? This is a correlation map of the different 36 categories that I described and how strongly they related to one another. Blue indicates a positive trend, red indicates a negative trend, and the shade represents the relative strength of that. So we use this to hone in on different strong signals and then go back to the literature and find out what kind of patterns there were. And I'll summarize some of the findings we had on the transition from current historical to current uses. So we actually found that 62% of the crops in our database have increased their number of uses from historical literature to current literature. And while we recognize that there's a paucity of evidence about many of the historical uses, we were as comprehensive as we possibly could be. And there were some examples of crops, for instance, sunflower, that came later into use as an oil, which is well documented. So we drew from what we had access to, but we do recognize these limitations. Across all of the categories of use, which are listed on the right, there was an increase in their occurrence, with the exception of two categories, currency and ritual purposes, both declined in these data sets. In some categories of use, there was a remarkable consistency. For instance, 71% of the fiber crops that we found important in historical times are still used today as fiber. Also, there's a strong overlap between food and medicine. I think that was swapped with one of the earlier graphs, but 59% of the previous uses of plants included medicine, and today 69% of the plants that we reviewed are also used as medicine. Most likely there was a much higher proportion in earlier usage, but we just don't have access to that literature in the literature. Nonetheless, it maintains what an important role food still plays as medicine. Some of the biggest increases in these categories came from the categories of cosmetics and alcohol. And this is a shameless plug for the company. We're hoping to benefit from this trend by continuing to bring plant diversity into more drinks. But we're not the only ones that are losing diversity in our diets. Fodder plants are one of the categories that's declined the most in diversity. What you see on the left here is a fodder beet. They've gone extinct in the US over the last 100 years, but they used to be a very nutritional source of feed for animals, and there's studies from the USDA that document an increase in lactation as a result of this diet. Now, you can't talk about food without also thinking about land and the competition that it comes under when considering these different uses. Corn is about, if you can see there in the lower light green corner, while it makes up nearly 30% of our cropland in the US, nearly 65% of it goes into food and fuel, food for animals that is, and fuel, so non-human food uses. So we find ourselves in a compromise where we have limited amount of production space, a growing population, and competition between these different facets of use of plants. Food on the one hand, animal feed, fuel, there's many others, and usually it's commodity prices or land prices that are informing these decisions rather than our social needs or environmental considerations. Which brings us to the question of what does the future of plant domestication look like? increasingly we're seeing new plants that are being brought into domestication for purposes other than food. When we were considering domestication in our review, we classified according to some of the more well-supported, well-documented domestication syndrome traits in the literature. And we recognized that there were distinct trends over time as to what changed, what gained prominence at different times, and how these related to different events going on in human history, or migrations and conquests, or technologies such as grafting. But we need to recognize that in the future there's going to be new domestication syndrome traits that may be under our radar, may be more difficult to perceive, but are increasingly important in our use of plants, like reduced lignin for digestion of biofuels, increased biomass. This might be one of our most recent domesticates, switchgrass, and it's currently being planted for the purposes of biofuel. So, what does all of this mean? Now we're seeing biodiversity and really our crop base being commodified for a completely different use, which is fuel. And it's putting, is it bringing biodiversity into direct conflict with other values like biomass? Is this a solution? Most of the land that's being used today for biofuels, or is being revised for use, is with the rationale that it's marginal land, that it's not suitable for agriculture. But in the process, you're ignoring many of the environmental services, ecosystem services, and things that are growing there at the moment. There was a recent study that showed that in the US alone, there are over 4,600 different crop wild relative species. So we may not be a center of diversity for agriculture, but we do have an enormous abundance of plants that can support agriculture and help us continue to build our base for adaptation in the future. So if all of this land that's marginal is being converted, what happens to these crops? So in conclusion, just to reflect back, the future uses of food may not necessarily all be food. And with that, I would like to invite any questions.
So, with modern crop breeding practices, how do those shake down? Because there's been those studies that show that as things have gotten bigger, the water content has increased and other things have gone secondary metabolites have been dropping off with lower plant stress under agricultural conditions. So how does that work with the trends that you're seeing there?
Well, if you'll notice the time frames that we're looking at, the data is still very, we're looking at 1,000-year time intervals here. So you would have a very different looking chart if you were just looking within the last 500 years or the last 150 years.
What would that look
for which syndrome? Or,
well,
some of the recent domesticates that we've seen, for instance, cranberry, it has reflected something that was wild harvested, and then recently there was a change in its breeding system to bring it into cultivation. Or macadamia nut, for instance, was just wild harvested as well and has undergone domestication in plantations in Hawaii in the last 100 years, and improvement there. And there's actually now concern in Australia that the domesticated macadamia nut plantations are reducing the genetic diversity of the wild populations growing nearby.
You mentioned the 83 critical species. Now you work with the species level. You don't work with the cultivars and varieties of corn or the plethora of horticultural varieties that have come into domestication. But you were focusing just on the species level?
We need to look beyond that level of detail.
What?
The data, I said that's a great point, and it highlights a major research gap, something we need to look into. What those numbers are were the best estimates that I could find in the literature of estimates of different parameters of what plants are important right now. And it's very hard to find information below the species level for the areas that are the most important for crop diversity.
So your was based on species level?
It's based on species level, right? Thank you.